welcome to my classroom. In this fuel cells and batteries course, almost we have completed the fuel cells portion. So in the past few lectures, we have seen high temperature fuel cells where we have discussed about intermediate temperature fuel cell, molten carbonate fuel cell, and high temperature fuel cell, solid oxide fuel cells. And in the previous lecture, we have discussed in detail about various materials or desired characteristics of cathode, anode, electrolyte, interconnector, and sealants for solid oxide fuel cells. Okay, now we have to shift towards application point of view, where we are going to make use of these fuel cells as well as batteries. Okay, that is into electric vehicles, that is particularly in automobile sector and our transportation sector. We are going to make use of these electric vehicles particularly, or making use of either fuel cells, or we are going to make use of batteries. Okay, so that way we are going to discuss about batteries in the next module onwards. From next lecture onwards, we are going to discuss about batteries in details. So in this lecture, we will just give a scope for what is the need for an electric vehicle, why a customer will buy. Because currently we are used to motor engines, right? So IC engines are there, internal combustion engine, which is on road. We have very good infrastructure for it, distribution of fuel, or mechanics, or all people are well knowledgeable to repair even anything happens with the vehicle. But suddenly we are introducing fuel cell based vehicles, electric vehicles, or battery based vehicles. So do we have the infrastructure required for implementation, or to, because we have some target to achieve. Already I have pointed out that India has a hydrogen roadmap where we want to get away from this crude oil based economy towards hydrogen based economy. That means that we want to make use of biohydrogen, or we want to produce more hydrogen, and we want to replace all these IC engine based vehicles, or either it is in transport sector or in stationary applications. We want to replace all the existing technologies with alternative energy technologies, particularly with using fuel cells or using batteries. Okay, so that way we will discuss about in detail about the electric vehicles, what are the bottlenecks associated in implementing such projects, and what needs to be done before getting into details about the batteries in detail. Okay. Particularly, we'll discuss about what are the challenges that are there in the obstacles for fuel cell based vehicles, like lack of hydrogen infrastructure, or how to store hydrogen safely. Particularly, we'll talk about fuel storage, and what if we are having some onboard reformers, what is the cost of the fuel cell and its supporting systems, and there is some noise concern is associated with it. What is that? Whether it is because of over noise or under noise, we will discuss. And we will see process control parameters, and the startup time required for the fuel cells to run. So we will discuss them in detail. Ready? So in this, we are going to discuss in detail about scope for electric vehicles. So from next lecture onwards, we are going to discuss about secondary batteries, flow batteries, and lithium ion batteries, and air batteries in detail. Okay, so here we will just give introduction to fuel cell electric vehicles, or electric vehicles in general. So this is a schematic of a hydrogen fueled PEM fuel cell system for automotive applications. You know, in a car where the equipment, each part has to be placed, is shown here. We will have a hydrogen source which will pass through humidifier heater. Then humidified hydrogen will be entering the fuel cell stack, and humidified air will be coming to the fuel cell stack, and there will be electric power generation. And the supporting systems are, we will have a radiator and condenser, and we will have fan, demister, all that. Okay. And if you look at the on-road energy consumption, if you take that as a basis, this fuel economy of this hydrogen fuel cell, particularly for light duty vehicles, is projected to be 3 times that of any conventional IC engine based vehicles. That means that if you consider overall fuel economy, it is going to provide you 3 times more efficient than your IC engine, that is petrol or diesel based engines. Okay, so even with less efficient, because right now we are operating these fuel cells with less efficiency, right? We are getting only a higher power density of 0.6 volt per fuel cell than the base case of 0.7 volt per cell, at this rated power point, these hydrogen fuel cell vehicles are projected to be providing us essentially the same fuel economy multiplier. That is, either it is ranging from 2.5 to 2.7 times. Okay. So the key to obtaining this fuel economy, this high fuel economy, is measured as the standardized urban and highway drive schedules lies in maintaining high efficiency of this fuel cell system at low loads also. To achieve this, besides a high performance fuel cell stack, what we need is we have to reduce the low parasitic losses in the air management system. Okay, so these electric vehicles, we know that on road, automobiles and IC engines are well known and drivers are used to it. Any driver operating this IC engine, petrol car or a diesel car, they are well versed with it. They are driving that such cars for 40 years, 50 years, like that, right? And nowadays we are having e-vehicles coming into picture. So the new generation drivers will be easily adapting to it, but it is difficult for the old drivers to adapt to these kind of e-vehicles, because right now we are not having such infrastructure required for even refueling all that, right? So drivers should have the knowledge of where I have to refill, because once we start from Warangal to Hyderabad, we know that where and all we have to fill the petrol if you are going in bike or in car, how much petrol it will take, all these you have the full idea, right? But drivers are not used to how much charging it is there or what speed I have to drive, where I have to recharge in between, like that. Such a knowledge is not there with the drivers. So the knowledge for the drivers, because obviously finally the vehicle is being driven by the drivers, right? And most of this motorized transportation today depends upon burning these fossil fuels like petrol, diesel, or natural gas, or CNG also being used in several places in Delhi and Noida, right? And 1/3 of India's crude oil imports is attributed or used in the transportation sector only, and in that 80% in the road transportation other than air, jet fuels and the ship driving. Okay, so this cost of, we all know that this cost of gasoline is ever increasing. We know the taxes and we know the rupee value, because we are paying for the crude oil in terms of dollars. Okay, so I'll just discuss that about in detail later. And that and other factors we have to consider are, we have to look into what is the impact of this transportation sector, particularly these vehicles which are using petrol and diesel. You have seen in Delhi the case, right? What is the air pollution taking place? The government trying to stop using 10 years old diesel car, all that have been implemented, right? So we have to consider such factors like environmental pollution, CO2 emission needs to be reduced, greenhouse gas emission needs to be reduced, right? Because this transportation industry is the major source of greenhouse gas emissions. Okay, so foreign oil supplies, this depletion of fossil fuel is also taking place, and during war situations, the crude oil price is ever increasing, right? So that all we will see it later. But what is an electric vehicle to start with? Vehicles which depends upon electricity for the mobility and which will have some low greenhouse gas emissions. They are called e-vehicles or electric vehicles. Nowadays you have the name board, you will be seeing some vehicles with the green name board, right? So they are all actually driven with electric vehicle, either it may be batteries or fuel cell run vehicles. Okay, so these electric vehicles are supposed to provide a legitimate alternative to the internal IC engines. Okay, IC engine, internal combustion engines. Okay, these electric drives. What is electric drive? Electric drive means electricity is used to move the wheels of a vehicle. So it is what is making your vehicle transfer, your car or bike to move. It is the electricity which is making them to move, not that any other gasoline, petrol, diesel or CNG gas or natural gas, anything. Okay, so this electric drive have been already being used for so many years in different applications of small scale of, means the driving distance is less easy for maintenance, right? Such places where and all, the golf ground, in that golf cars are there which will carry the player and the bats to within the golf ground. So even if it stops, no problem, you can walk and get out of that place, right? So in such places, even in supermarkets, you might have seen that forklifts are being used, where these kind of tall 3-story building, instead of 3-story, they have a tall thing. All the goods are being kept at the top. Whatever needs to be taken down, cartoon box has to be taken down. They'll just send this forklift and they'll take it down, right? So such way, several supermarkets designs have been introduced nowadays. particularly with Reliance supermarkets, you will see such case. And there are e-bicycles are there, e-trains are there, and you have some automobiles coming into picture with this one. So such vehicles are given with a green board, we can easily identify them. Okay. So there are different type of electric and hybrid vehicle. What does it mean? It is purely electric vehicle means what is hybrid vehicle? Purely electric vehicle means there is no, it's not dual one. It's like a hybrid vehicle refers to the one which has both setup. It can run with petrol and it can run with battery also. So that way, when battery is empty, suddenly what we will do? We will put 1 liter petrol into it and we'll can still run the car. Okay. So that is, it is a hybrid car means it will run on batteries most of the time. The moment your battery is down, you can switch to petrol mode or diesel mode, and you can fill the tank with petrol, diesel, and you can drive the car. Okay, then you come home and you can recharge the battery, or if it is fuel cell, you have to recharge the hydrogen tank, right? So that can be done. So that way we have different type of electric vehicles. One is electric vehicles, one is hybrid vehicle, and in that there are extended range electric vehicles are there, and there is plug-in hybrid vehicles also there. Okay, so that and all being studied in detail by mechanical engineers, electrical engineers, all that. Yes, they have to design the circuits for that, right? So we have IC engines vehicles and you have AE vehicles also. Okay, so when you come to IC engines, you have internal combustion engine or micro hybrid electric vehicles. Hybrid electric vehicles means mild hybrid electric vehicles, full hybrid electric vehicles. You have different types, you can see that. And here at the end, what we are focusing on is this battery electric vehicles and fuel cell electric vehicles. That's the concern of our course, right? So we are concerned more about this battery electric vehicle and fuel cell electric vehicles. Okay. So these electric drives are pure electric drives, hybrid vehicles, regenerative braking, hybrid electric vehicles, what is zero emission vehicle, fuel cell electric vehicles, and what are the obstacles for fuel cell vehicles. So we are going to discuss these topics in detail in this lecture. Okay. So what is the electric drive? Electric drive means it can be pure electric drive or it can be hybrid vehicles. So for example, examples for pure electric driven vehicles are golf cars, e-automobiles, e-bicycles. So there is no alternative way of running it. Okay, as long as charge is there, if it is battery driven, as long as charge is there, that vehicle will moving. Or if it is a fuel cell based vehicle, as long as hydrogen and oxygen being supplied, it will be running. Once hydrogen is empty, it will stop working, right? So they are pure electric vehicles. Okay, so that are the common, one of the common categories of the electric driven vehicles. Okay, so hybrid vehicles. What is hybrid vehicle is you will have engine generators where you have hybrid electric automobiles or diesel electric buses are also examples of this type of engine generators. Okay, so you have IC engines also incorporated in it. Also there is a space for to keeping the batteries also in it. Okay, so they are hybrid vehicles, and even in hybrid vehicles you have fuel cells where you have hydrogen powered vehicles are examples for this one. Okay, so these are some of the common categories of electric driven vehicles. Okay, so if you talk about pure electric vehicle, batteries are being widely used in that area. If it is hybrid vehicles, we mainly use fuel cells. Okay, so because you will be using fuels also in it. Okay, so between that we have different range. Okay, how much 100% battery vehicle, 100% fuel, what IC engine vehicle, or a hybrid of them also possible, right? So in case of fuels, it can be even fuel cell driven vehicle also. So if you look at our Indian government, even government also have a policy. They have introduced a National Electric Mobility Mission Plan 2020 in 2013 to achieve the national fuel security. What is the objective is to promote the electric and hybrid electric vehicles. So government started funding people working in these batteries, fuel cells, or even electrical circuit for it, or design of your engines for particular type of hybrid vehicles. Okay, so even in 2015, Indian government launched a FAME scheme, that is faster adaptation and manufacturing of electric vehicle scheme, under which the government gave some $12 billion subsidy to provide discounts on the purchase of electric vehicles in 2015 and 16. Okay, So electric two or three wheelers and fleet vehicle market is expected to grow at a tremendous rate. We can even see that, particularly when I was in Dehradun, Haridwar, and all, there are a lot of electric vehicles have been introduced. In tourist places, these vehicles are introduced where we can commute the visitors from within the campus. Okay, particularly if you see airport or even railway stations, for elderly people moving from platform to platform, we use this type of vehicles, two or three wheelers. Okay, so that way that this market is there, huge scope is there. Even on road vehicles with electric driven autos are also coming into picture, right? So particularly where they will recharge. So there is a requirement for charging the infrastructure. Smart meters and testing are likely to gain importance. So anyone working in these areas of developing charging infrastructure, how to detect what is the percentage battery is there, and quality testing, all that. No, so that is there. So because of this government motivation and incentives, Indian electric vehicle market is poised to rise immensely in the next 5 years, and technological innovations in these electric vehicles and the charging infrastructures will have an immense growth potential. So even in share market, people used to invest more on this type of alternative energy battery production companies, Excite batteries, all that things, right? So because government want to have a vision that we on road, we want to have this much number of two wheelers, this much number of buses, this much number of cars has to be on road with which runs with electric model, that is e vehicles, either it is battery or fuel cell vehicles. Okay, so you can see that in millions, government we want to have electric two wheelers of 3.5 to 5 millions, electric vehicles of 0.2 to 0.4 millions, like okay, three wheeler, four wheeler, all that. That is like light duty and heavy duty electric vehicles like four wheelers, buses, all that. We want to have 1.3 to 1.4 million units on road. Okay, so totally we want to have 5 to 7 million units of such e vehicles on road. Okay, so that is the government thing, and that's why government is providing subsidies for such products relevant to it. Okay, so we have seen that there is a pure electric drive. What is that? Automobiles with pure electric drive is powered only by the batteries, and it means that once battery is down, it has to be recharged using external source of electricity such as wall plugging, right? Electricity. Here a lot of memes also coming into picture, right? So we are telling that I want to reduce greenhouse emissions, so I am going for e-vehicles. I have a battery, but I have to charge the battery. Now, how these charging stations are working? They have a diesel generator which generates electricity. From that electricity, you are charging your electric vehicle and getting charged. So what you are doing? Are you reducing greenhouse emissions? Because your energy source, your electricity source also determines your vehicle is 100% green vehicle or not. Okay, because when the moment I am taking electricity which is generated using diesel generator, that has a 35% efficiency or 40% efficiency, right? Also, it emits so much of CO2 emissions, NOx emissions, SOx emissions into the atmosphere. So I am not actually helping in reducing greenhouse emissions. The moment I start using electricity generated using either coal powered thermal power plants or diesel generators. Okay, so that way that electricity produced also should be from alternative energy technology like solar cells, wind energy, wind turbines, or even from the geothermal energy kind of thing. Okay, so that is our goal, long-term goal. Okay, we want to produce electricity only using green technologies or alternative energy technologies. Okay, and if you look at these hybrid vehicles, automobiles with an electric motor and an IC engine, and there is a high voltage battery will be used in a hybrid vehicle. They are recharged by the engine which is running. Actually, your car is there. If you are not using it for 20 days, what will happen? Your battery will go down. But that's why you have to start your car and run it for 10 minutes in your car parking, so that your battery gets charged. Okay, so that's why even if you are not taking it out, it is important you start your car and keep it in on mode for 10 minutes per day, so that your battery is getting charged without draining. Okay, because once it drains, self start will not work, right? So that way such hybrid vehicles are there. So high voltage batteries are used in the hybrid vehicles, Okay, so they are run, how they are getting, we are not charging it outside. Okay, it is always charged by the energy driven generator, engine driven generator. And also there is a concept called regenerative braking. When you are applying brake, that energy is captured in the hybrid vehicle. And there are full vehicles which is powered solely by the electric motors, but the energy of the motors is produced by the fuel cells. So we have pure electric vehicle which is powered only by batteries. We have hybrid vehicles where you use IC engine, that is gasoline or diesel, and then that battery is also there which gets charged when you are operating with IC engine. Okay. So then we have fuel cell vehicle purely which gets energy from hydrogen and oxygen. Okay. And other than hydrogen, we have seen that there are several alternative fuels are there, and among that propane or LPG vehicles are there, because that LPG is the third most used fuel for IC engines, and that is 2000 pounds per square inch pressure cylinders are being used. When the liquid is drawn from the cylinders, it warms, changes back to gas, and which is burnt in the engine. And we can use ethanol or methanol vehicles are also available. Ford's Model T uses methanol or ethanol as the fuel, and there is an Indianapolis type car since 1965. Okay, and there is a flexible fuel vehicles also can be used, which can either use alcohol fuel or even gasoline. And there is M85 and E85, which is mixed with 15% gasoline, which are being used, which helps us to overcome the cold starting ability of the alcohols. Okay, and there are vehicles which can run on natural gas vehicles. Okay, so that is natural gas, some CNG or LNG are being used because they are clean fuels. They are stored in 2400 to 3600 pounds per square inch. Okay, so even this LNG requires refrigeration units required to store the fuels, and there is a space constraint also associated with this type of compressed fuels, CNG gas, because when you see such autos now, you don't have space to keep your luggages. Okay. And I told you regenerative braking is present in hybrid fuel cells, right? So what is that regenerative braking? It's a new word for chemical engineers particularly, because usually when a driver is applying a brake, what is usually done on the road? The friction is converted into heat and the energy is lost. When you apply sudden brake, you will see that heat is coming out and smoke is also coming out when you apply such as sudden brakes, right? So we are losing the energy there. But whereas what if somebody thought that what if I can convert that energy instead of heat into something else, and which can be again recovered when I want to use it again. Okay, so that's where this regenerative braking came into picture. Okay, regenerative braking is a process by which a vehicle's kinetic energy is captured while decelerating or braking, because we know the law of conservation, right? The energy can neither be created nor be destroyed, right? So that based on that, only we know that energy can be converted to another form of energy, right? So that is what being used in this regenerative braking. And most common forms of this regenerative braking involves using an electric motor as an electric generator. The generated electricity is fed back into the supply system, whereas in battery, electric and hybrid electric vehicles, the energy is stored chemically in a battery. Okay, so that way we are making use of that energy to convert it into chemical energy. Okay, actually this concept was even patented in 1908 by C.J. Paulson, who patented a smart car with regenerative braking. Okay, actually this regenerative braking system, as I shown you in this diagram, it has several components. Okay, so if you look at what are the components of a regenerative braking, we have a battery array, 300 volts battery is there, we have a controller, you have a AC motor, you have a transmission. Okay, so the potentiometer is there, because the brake is connected to a potentiometer. We have a 12 volt battery and we have a charger. Okay, so it has units like energy storage unit. ESU perform two primary functions. One is to recover and store the braking energy, and to absorb the excess engine energy during light load operation. And the road light load, the car is supposed to have four people, only one people is one person is driving, so there is a excessive engine energy is there, no? So that needs to be observed, right? And the selection criteria for this for an effective energy storage includes high specific energy storage density, high energy transfer rate, and a small space requirement. Okay, so this needs to be addressed. Okay, and the energy captured by regenerative braking might be stored in one of the three devices. Either it can be stored in an electrochemical battery, or it can be stored in a flywheel, or a hydraulic accumulator. Okay, hydraulic accumulator, you know that hydraulically it can be stored. Okay, so in a traditional braking system, what happens is when the brake pads will be producing friction with the brake rotors to slow or stop the vehicles. So additional friction is produced between the slowed wheels and the surface of the road. This friction is what turns the car's kinetic energy into the heat, right? Whereas in a regenerative brake, a energy recovery mechanism which slows down a vehicle or the object by converting its kinetic energy into another form, which can be either used immediately or can be stored until we need it. Okay, so this energy regenerative brake system was developed in 1967 by American Motors Company AMC Corporation in cooperation with the Burton Industries. So such energy regeneration from braking idea, or even with paying royalty, other big manufacturers also started using like Ford, Chevrolet, and Toyota. Okay, so even in late 2000s, an electronic control unit used by BMW that engages the alternator during braking was also introduced. Okay, so this is a typical flow diagram of a regenerative braking circuit. Okay, so whenever you apply brake, a motor or generator is there, which will be stored in the energy sink. It can be battery, ultra capacitor, flywheel, or hydraulic accumulator. Okay. And what is in the advantage? What are the advantages of these hybrid electric vehicles? Is they they give an extended range than a battery electric vehicles. Okay, and the delivery of power to the wheels is smooth and very responsive. Okay, that's it. There is no delay, and this operates more efficiently, and the fuel economy is more and the very low tailpipe emissions. Okay, and however, this hybrid is never be a true zero emission vehicle, because the moment you are using the IC engine in it, you are emitting the greenhouse gases, right? And in these hybrid vehicles, we know that battery is continuously being recharged by a generator, which is driven by the IC engine. Okay, so plug-in charging is not required. That is the difference between pure battery vehicle and a hybrid vehicle. Okay, so when you are running with the diesel petrol, it gets charged. Okay. And now we'll look into this. We have seen now why a customer will move from, because as I told you, all drivers are owners. We are all well used to petrol vehicles or diesel vehicles. Even the repair we will able to diagnose it easily. Mechanics are there with, even if you are not going to standard showrooms, even roadside mechanic will open your car or your bike and repair it and give it to you. But with this type of all these e-vehicles, it is they needs to be trained, right? Skill development is required in that case. Okay. So now let us look into why a customer has to move from your petrol vehicle or diesel vehicle towards e-vehicles. That is particularly battery-based vehicles or hybrid vehicle or even fuel cell-based vehicles. Okay. So this currently, if you look at me, my diesel car or petrol car is cheaper in comparison to hydrogen fuel cell cars. Then why I will go for that one? Why I am more concerned about these greenhouse gas emissions? So customer should have a choice. There should be cost should be comparable. It's like only if it is more than 10% difference is there, why I will be more concerned about the environment? Say when both are same cost, say for example, petrol car is also 10 lakhs, and this e car also means battery car or fuel cell car is also same cost. What I will do? Okay, I will not buy this petrol car. I will go for this fuel cell car, because I will be emitting less carbon emissions will be there, like that, right? But when the price is too high, the difference is too high, any customer will not be bothered about the environment. He will look at his own economy, right? He is a middle class person. Oh, yeah, I cannot afford that car now because I cannot pay extra for my thing, right? So the budget constraints come into picture. So when the budgets are same, a person, a customer will be more convinced or educated, easily convinced to buy a hydrogen fuel cell based car or a battery based car, right? So this difference in this price offset by fuels, anyhow you should be knowing that even though his initial investment cost is more, later on while operating your petrol price is ever increasing, you are paying more petrol for petrol, right? So that way in per usage calculate that mathematics, if one does, he will realize that payback period is more quickly, I will get back to my thing like that. Okay, but the thing is that is not understood by everyone. Okay. And for to address this issue, what government is doing is, those who are buying electric vehicles, we give 25 percentage subsidy, because they are giving subsidy to electric vehicle producers. Okay, the company gets tax free, they have less tax to pay. Okay, so like that, so many incentives are paid by the government. And if you want to start a battery business or solar cell business as an entrepreneur, government gives loans with a very less interest. Okay, so they provide a lot of subsidies to you, kind of thing. Okay, so there are a lot of incentives given by our Indian government also to get into this alternative energy business, including e-vehicles. Okay, so particularly a force, what are the driving force for a customer to move towards e-vehicles are: number two, one is expecting one thing, that is my lower annual cost of the fuel will reduce, because I no need to go to petrol bunk and buy petrol for a very high price. Okay, so the electricity charges are less. So I currently, okay, so I can recharge at my home where I pay only 10 rupees per unit. Okay, so that way you will be thinking. So that is one reason to go towards e-vehicles. Another one is about reduced emissions. Okay, as I said, greenhouse gas emissions are less. So this all will be followed by only educated one who understands the greenhouse gas impact of greenhouse gas emissions, who understands the global warming, all that. Such person will easily move towards reduced emissions. Reason will buy the e-vehicles. Other people to move towards e-vehicles, there are different reasons to do. Okay. So look at the if you look at petroleum planning and analysis cell, which is our government Ministry of Petroleum Natural Gas under Indian government. If you look at their website ppac.gov.in, so if you look at the prices that they are paying currently for barrel, you can see that latest price on 28th March today, right? So today, 28th March 2022, if I look at this website and look into what is the price they are paying for crude oil, so you can see that in dollars how much we are paying. We are paying around $115 per barrel. Okay, so that is the price of crude oil. Remember, when we are importing crude oil and we have so many refineries, okay, including private sectors like Adani and Reliance, all are there, right, in Jamnagar. Okay, so such including government, public sector, even ONGC, IOCL kind of places, refineries, private sectors like Reliance or Adani Power, all that. So this crude oil is purchased at this high price. Okay, then we are converting it to petrol and diesel, and then we are selling it in the market. Okay, so if you look at the cost, how it is increasing, you see, right? For first 1 month, there was no increase in petrol or diesel price. But since 21st March till 28th March, if you look at their own website of government data, so at the major cities, what is the petrol price? You can see it is 100 plus century. It has hit centuries in Mumbai, Chennai, and Kolkata, except Delhi. Okay, similarly, if you look at the diesel price also, it has been increasing significantly. Okay, so if you compare it with the 2010 or past 10 year or past 20 years or past 5 years, the increase is drastic. So which is making our daily life, our, see, remember this petrol price impacts you, the cost of your tea, cost of the vegetables you buy, because everything needs to be transported from one place to another place, right? So that petrol cost is increasing means the cost of every commodity increases. Okay, so even it depends upon some of the government's decision to how much we have to take tax also. For example, if the price has to be this much, it is the price at which it is being given to the dealers. Okay, in 2018 government data, same government data, if you look at, so they are giving price charged to the dealer gets it for 37.19 rupees, and dealer gets a commission of only 3 rupees, 3.5 rupees. So it's supposed to be only 30 rupees, 40 rupees totally, 41 rupees maximum. But when government imposes several taxes, okay, so what happens? The taxes is around equal to the price of the product. So we have been paying 76 rupees in 2018, which has come to 108 rupees or 105 rupees today. Okay, so you can think about how much we have been paying tax. So it is the manufacturing cost for any product. We need to have a cost price, right? Cost price plus we fix a profit, right? Will become selling price. That is any product. Even farmers, what they do, they produce some crop. It is 10 rupees worth. Then they want a profit of 5 rupees. Then they sell it to 15 rupees. Okay. So that is how it is supposed to be, right? 35 rupees. You keep profit of even 10 rupees. It is supposed to be 45 rupees product. Okay. But when government decides to tax a lot, what happens? We will be paying more like this. Okay. So we have been paying taxes. So as a consumer, we are not able to buy these petrol and diesel cars. Okay. Buy and diesel. So we want to shift to alternative. So I cannot sell this car. I will move to some other cars. Okay. So because there is a reason for increasing the price also, because tax is being increasing like anything. Say for example, in 2014, the central tax was around 10 rupees. Now within this 2017, now it is even more. So it has increased to 21 rupees in 2017. So that way, when government is keep on increasing the tax, so consumer will be looking for alternative vehicles. Okay. Because when government is increasing the price, there is another factor also. So based on the crude oil price. Okay, so what is the price of the crude oil? What is the diesel retail price? You can compare. When in 2012 to 2014, okay, so the crude oil price was very high, 90 to 120. You can see that it's in this range. It is the crude oil price. But government made subsidies. The government kept the prices of your diesel in this range of 50 to 60. Okay, now the crude oil price has fallen down. Okay, it was up to here, but we did not reduce the price of the diesel here. When the price actually now government has changed the rule that this based on the crude oil price, it is like proportional to crude oil price. We will have our petrol or diesel prices. But when the crude oil price has gone down to this much, we did not reduce the price. It is supposed to be reduced, right? It was not done. But now actually crude oil prices increased a lot because of even now currently it has even crossed 100 plus because of war situation. We have seen that, right? Government is paying around $115 now because that is the rate today. Okay. So even this government, but the diesel price is being kept high. We have seen that it is around 93 rupees. Diesel price is around 93 rupees in this week. Okay, but the same actually we are giving petrol to Sri Lanka. When you want to compare the prices of diesel in Sri Lanka, today the diesel price is around 66.79 rupees and the petrol price is around 53 rupees per liter. Sri Lanka, it is which is under tremendous economic crisis. Still in Sri Lankan gasoline prices, this is Sri Lankan rupees, which is around 283 rupees, which is compared to, if you convert that, today's price is 283 Sri Lankan dollar is equal to 74 rupees. How much we are paying here? We are paying around 108 rupees. Okay, so that way, this also, and the big part is our Indian oil company subsidiary is there in Sri Lanka. They are only selling the petrol, gasoline, petrol, diesel to Sri Lanka. Okay, because India is a committed partner and a true friend of Sri Lanka. We are even donating some tons of petrol and diesel to address their energy demands. Okay, so that way India is selling the petrol and diesels at a lower price in Sri Lanka, whereas in India we are paying more. Okay, so that is also another driving force for customer. to shift from this type of gasoline based or diesel based vehicles to electric vehicles. Okay, so because this fuel cell electric vehicle uses the electricity produced by the fuel cell to power the motors that drives the wheels of the vehicles, right? So this we know in detail, and particularly when you are using hydrogen as the fuel, we know that it is a truly zero emission vehicle. Okay, if hydrogen fuel cells are used, these fuels, if hydrocarbons are being used as the fuel, in that case we will be having a reformer unit, but that may emit some pollutants. Okay, but it is the pollutant level is going to be less than the IC engines. Okay, and however there is emission related to the production of hydrogen, because how you are producing hydrogen, in that case some emission may be there, right? So that needs to be addressed before we call fuel cell engines to move into the mainstream market. Okay, so you can see that how different type of vehicles are being used based on the vehicle size and the driving distance. We have different shapes of vehicles, and the design is there. Okay, so can go through it. And there are different types of electric vehicles. As I said, you are going to have connections are going to be different according to that one. So you can call it a series hybrid electric vehicle, where it is in series in connection. You can see the driving gear connected to motor, connected to power converter, which is connected to power batteries, generator, engine, fuel tank. And there is a fuel parallel hybrid vehicles are there, where fuel tank will be there, IC engine will be there, which will also drive the car. Also you have power battery, which converts power converter, and motor, which drives the gear. Okay, so that is called parallel hybrid vehicle. This is series hybrid vehicle, and you have series parallel hybrid vehicles and complex hybrid vehicles. So they have different ways of operating. Okay, and that way any fuel cell vehicle will have the following components. It will have a fuel cell stack, obviously a number of fuel cells arranged in series. We have fuel cell stack. Then you need to have a hydrogen supply system, or if it is hydrocarbon, you will have a reformer with a fuel tank, and we need to have a air supply system with a filter, and proper humidity should be there. So a humidification chamber should be there, and fuel cell cooling system has to be there, because the reaction taking place is exothermic in nature. And we'll have a storage battery or ultra capacitor for storing the energy, and there will be traction motor and transmission, and you will have a control module and related input outputs, including a DC AC converter. Okay, we know that electricity produced in a fuel cell is a DC current, so which needs to be converted to AC current. Okay, and if you compare the prices of IC engine versus electric vehicles, these are Norwegian government policies are constructed to make the least polluting cars the most attractive. So what they did is how to match this price. Okay, how we can reduce this price, because its cost price is more, base price is more. You can see that base price of your electric vehicle is around 32,450, means here the base price is very less. So, but then you have, they put a tax, VAT tax, they keep a registration tax, there is a circulation tax, there is a scrappage tax, then you have fuel and electricity cost. So that makes effectively the cost of an IC engine to be 43,445 US dollars. Okay, but what government does is they keep very less taxes, negligible taxes, relaxing from registration fees. There is no circulation tax, and there is no scrapping fees, and your fuel cost or hydrogen cost or electricity cost is going to be very less. So which means that the overall cost is 21% less than the IC engine. So government has made that putting large tax on these registration fees or VAT tax or fuel also costing more, which makes them a customer to move towards this. That's what even in India we are doing, that we are keeping the taxes high so that people will be moving towards that is one way. It's not that is objective, I don't say. We say that such huge prices only will make a consumer to move from the IC based vehicles to electric vehicles. So that way we are doing that price. So, but you see, with the base price alone you compare, obviously IC engines, diesel cars or petrol cars are going to be cheaper. but the capital cost is more for these vehicles, but government compensates it and looks it cheaper on road price by increasing the tax, increasing the fuel price, increasing all the taxes, and keeping simple for e-vehicles. Okay. And what about the battery pack price, indicative prices? Currently the battery prices in India is between US dollar 275 to 300 per kilowatt hour. So that's what you can see from the past decade, 2010 onwards. There is a drastic decrease in the cost of the battery. So that is what helping us to move towards the e-vehicles. Initially, when battery cars and all came, even though it reduces less greenhouse gas emissions, but the cost is not affordable for a common man. Okay, so now you can see that at least 77% decrease in the cost of batteries. Okay, which helps us to move from these ICE vehicles to battery based vehicles. Okay, you can see because that is because the energy storage capex in the lithium ion batteries in terms of US dollars per kilowatt hour has decreased from 1000 to 100. It is expected to even further decrease. You can see we are in 2022, it has reduced to 156 US dollars per kilowatt hour, and which is further about to reduce another 50% by 2025. So that is the thing. A lot of research is being done in these areas of batteries, which we are going to discuss in our model number 4, where we will discuss about lithium and rechargeable, because primary batteries is use and throw batteries. If you look at the secondary batteries, rechargeable batteries, mainly we will discuss about lithium ion batteries, transition metal oxide batteries. Okay, lithium batteries, sodium batteries are there, all that we'll discuss in detail. Also, we'll look into flow batteries, and we'll discuss about air batteries also. Okay, so that we will discuss in next lecture. But what are the obstacles for fuel cell vehicles? Because we are going to complete these fuel cells here. So what are the obstacles for fuel cell vehicles to come on road? We will discuss here in short. Okay. So main thing is I am ready to buy a hydrogen based vehicle, but where do I recharge it when I want to travel from Mumbai to Chennai? I think now for Mumbai to Chennai, there is a rechargeable battery recharge is possible. Such a road is done. Somebody has even posted a video traveling from Mumbai to Chennai with the e-vehicle. Okay, so that is possible. That has been made possible because of the improvement in the infrastructure. But still, throughout India, across anywhere from your hometown to your college, are you able to use this vehicle? That's a big question mark, right? So such hydrogen infrastructure development is there. That means like petrol bunks are there now. I want to move from here to Hyderabad, sufficiently I should have places where I can fill the tank and I can move on further, right? Either it is bike or car or anything. Okay, so then there is a fuel storage issues. Either safely I can store, how much space it will occupy. All that issues are there, which is stopping the marketing of these fuel cell vehicles also. And the onboard reformers are required. And what is the cost of the fuel cell and its supporting system like bipolar plates or whatever unit we have to pay. And there is a noise concern and control issues and startup time. We'll discuss in detail. Okay, so what is the lack of hydrogen infrastructure? There are a few places where we have this hydrogen fuel cell, because it depends upon the government policies and infrastructure development, right? It's not that every car owner, I bought a car, I'll start some 5 hydrogen recharge stations through till my hometown. No, we cannot do it. Right, so it is the responsibility of government, which has to frame a policy, allocate fund, and motivate the entrepreneurs to start or come forward to become a dealer and have such plans. Right. Also, these equipments are all required for generating hydrogen is to be installed there. Right. So, what is the easiest way to produce hydrogen? Electrolysis. Right. So, electrolytes we can do syngases, natural gas. From that you can produce, right? So different technologies are there to produce hydrogen. So we preferably it should be greener technology, means electrolysis of water. Okay, so from water we will get hydrogen and oxygen. Okay, so that way we will recharge our car with hydrogen. Okay, so such infrastructure development is one of the thing. And second thing is our fuel storage. We want to have at least a good on-road commercial vehicle, means which will be able to move at least 483 kilometers without recharging. That's what once I recharge fully, I should able to drive at least 300 miles. That is the practical expectations. But what does it mean to drive 300 miles? If it is hydrogen one, we need a compressed cylinder which is 5000 psi, and 150 miles has been realized. And what will happen if you double the pressure? So that where we want to work on it. Okay, hydrogen storage is a major research area people are working, because that it occupies the space, right? How we are storing, either you want to store it in gaseous form, compressed gas, or liquefy it and store it, or you want to store it in some metal hydrides. Okay, because currently if you look at the car, in the dicky area, backside of the car, rear end, we are going to have two big cylinders. So that is a Ford car P2000 fuel cell vehicle is having two hydrogen tanks at the backside. Okay, and this hydrogen storage can be done in different ways. Either it can be physical storage, means you can store it in compressed hydrogen tank, liquid hydrogen tank, cryocompressed tank. Okay, any one of the phase. But chemical storages, we don't store hydrogen directly. We store something in the form of hydrogen containing gas or hydrogen containing material, or we can even absorb the hydrogen and store it. Okay, so that way when we want it, we'll turn on something which will release hydrogen as per our requirement. Okay, so such chemical storage are sorbent storage, that is like metal organic frameworks are being developed which are known to absorb, because they have interstitial spaces where hydrogen atoms can be stored. Okay, hydrogen can be stored, or we can have carbon based material which can absorb and keep hydrogen. And there is metal hydrides, or even we can have complex metal hydrides, and there are chemical hydrides like borohydrides are being used, which in chemical form. Even you can use ammonia. You can have an ammonia tank, you have a reactor which ammonia NH3, right? So that will become N2 plus H2. Whatever reaction must take place and condition we have to keep, so it will release hydrogen directly for the engine. Okay. So that way, several other methods are there where you can store it in different forms. Okay. So this is the improvement here. How much grams of hydrogen per liter can be stored here is shown in this diagram. So what we can see that is reducing the pressure slightly frees the hydrogen from the powder and allows the gas to be channeled to the fuel cell. That's what a metal hydride. Metal hydride is nothing but a metal powder which can be used to store hydrogen for use in the hydrogen fuel cells. So these metal hydride fuel stores take the form of a series of metal cylinders kept at less than 10 bar pressure. Okay. And there is a problem with onboard reformers being present when you are not using hydrogen as a fuel, because these onboard reformers occupies a extra space, and also they are going to release greenhouse gas emissions. And also there is a cost of fuel cell and supporting system. You can see that here, you can see that support system for a fuel cell is there. Okay. So you have so many supporting systems are required, so that makes the cost bit higher. And I was telling no that noise concern is associated with it. It's not because of it is making huge noise pollution. It is very silent. What happens? Some old man is crossing the road. When this car is moving, you will not able to see that one. Okay, it's too silent. And similarly, when you are driving the car, cyclists are walking, they will not know that car is coming, because it comes very smoothly without noise. So they will suddenly move the lane, done. Because these high fuel cell cars coming at 50 or 60 kilometers per hour, these people will be an issue. That's all needs to be addressed. Okay, so that is a nice concern which we wanted to discuss. And with respect to control, we need, because obviously when you use IC engine, we have less control things, means here we have to have new electronic devices, traction motor is used. Okay, because we are going to have a varying driving conditions. Particularly, we need so much sensors also. Hydrogen leakage sensors should be there, right? Oxygen tank is there. Any leakage, we need to identify it, right? So many sensors are also required. And you consider cold countries. What happens for such vehicles? Okay, freezing kills fuel cells. Freezing means when it is become ice is formed, because water is there, water is being used in the fuel cell, right? Whether it is a product or moving around, membrane needs to be saturated to be at most efficient condition. But when it is temperature is going down to -degrees or 0 degrees, it becomes ice. and the deposition of ice on the membrane will be there. You are putting your key and trying to start. What will happen? Unless the membrane is saturated, ions will not be conducted, right? So that way, and all this exhaust system also plugged with the fuel cells, and we have to do removal of water even before the shutdown to avoid it. Okay, so if you want to avoid ice formation on these membranes or in the fuel cell, any water in the system needs to be removed before we switch off the vehicle. And we need more requirement of energy, and special coolants are required to avoid this type of freezing. Okay, so that way fuel cell has to overcome this 0 degree barrier that is there. Okay, so the moment your fuel cell gets 0 degree, you cannot start it. So just you can see that what happens with the varying temperatures. So this is a Ola scooter. You can see what is happening here. Because the temperature is warm in March. Okay, the temperature has increased. We'll discuss about this in detail in next lecture. Okay, so what are the challenges in introducing battery-based vehicles into the commercial market? While of impacts cost, efficiency, and vehicle range, and is a safety consideration for vehicles parked in confined space. It's however hoped that the recent developments in other fields may help to solve this type of challenge. For example, one of the properties of nano-engineered carbon is that it will absorb the hydrogen. It is expected that this property will be harnessed to allow more efficient storage of hydrogen fuel, and several governments, US Department of Energy, Indian government also putting a lot of efforts in developing such materials which can capable of storing hydrogen more efficiently. Okay, and we have seen that hydrogen is going to give you more efficiency, all that, but the gravimetric and volumetric capacity, yes, the density of hydrogen is low, plus fuel must be insulated to keep the temperature very low, and this reduces the gravimetric and volumetric capacity. So a hydrogen car would require a huge tank if it has to have the same range as a conventional gasoline car. So the space of the hydrogen cylinder or this thing is going to be more. Okay, and similarly delivery of these hydrogen fuels. Okay, a suitable delivery network to distribute the super chilled and highly compressed hydrogen gas around the country has yet to be put in place. Such a dedicated network could be expensive and technologically challenging, although recent technological advancements in nanomaterials could help to overcome these challenges. Okay. So these are some of the case studies where you can find out 20 recent cars models which are using hydrogen fuel cells. Okay, so this is, I am just showing you some of the figures. We have Nissan X Trial FC vehicle, and particularly if you look at Iceland country, they converted all their old ships into whale watching ships, where they use hydrogen to generate the hydrogen from the seawater on the board, using the electricity from the wind power and solar panels to power the process. Okay, such thing they are using. And if you look at the researchers at Tyndall Center for Climate Change, okay, so they are producing some climate change impact of an airship is 80 to 90% smaller than that of the ordinary aircraft. Such vehicle they have created. And you can see that Boeing has revealed 3 test flights of its prototype hydrogen-powered planes, which took off in March 2018 at the company's European Research Center near Madrid. Okay, so that way there are a lot of applications of hydrogen fuel cell powered vehicles, even in small scale drones. It can be, instead of battery powered, it can be hydrogen powered drones can be used, because hydrogen is a compact and relatively light source of power. The US military has been developing hydrogen powered drones to surveillance purposes. Okay, and you have this Mercedes hydrogen car, you have Mazda hydrogen hybrid car, you have Hyundai Bluetooth hydrogen car, you have Chevrolet Sequel, you have BMW hydrogen 7, we have this BMW car. Well, In this lecture, we have discussed about the scope of electric vehicles on Indian roads with the international scenario as well as in the Indian scenario. What are the bottlenecks that needs to be addressed before we can achieve the dream of having more e-vehicles on Indian roads? Meet you in the next lecture, which will be on batteries. Thank you so much for joining my classroom. Bye-bye.